All right, today we are learning about geometric probability. Our EQ is how do I use length and area to calculate probability. So before we get into this, we are going to review what is probability. The probability of an event is a measure of the likelihood that an event will occur. It is a number between 0 and 1. It can be written as a fraction, a decimal, or percent. An example of a fraction would be 13 over 50, which is 0.26, or 26%. Probability of E, where E is the event, is the probability, P of E is the probability an event will occur. And it is calculated by the number of favorable outcomes over the number of possible outcomes. Geometric probability is the ratio that involves measurements such as length or area. Geometric probability with length. For this problem, we have to find the probability that a point chosen at random on GJ is on HK. So what we're going to do is you're going to need a highlighter, so please grab a highlighter. But first, we're going to make a box around GJ. And next, we're going to use our highlighter to highlight HK. So GJ represents our total possible outcomes. And we should remember from Unit 1 that whenever we see two letters next to each other without a segment bar, that's referring to its length. So now let's go ahead and find the length of GJ. If G is at -3 and J is at 7, then the distance between them is 10. And HK is our length of our favorable outcomes. And so the probability that this event will occur is going to be 10, that's our possible for a denominator, and now we need to count the length of HK, which is 3. So 3 over 10 is 0.3 or 30%. So we're going to do one more geometric probability problem with length. Find the probability that a point chosen at random on Fj is on Hk. So Fj, F is at -5 and J is at 7. And so the distance between them is 12. And Hk is still 3. And so the probability that this event will occur is going to be 3 over 12, which is 0.25, which is 25%. So now we are going to find geometric probability with area. Given a large square with a side length of 6, find the probability that a point chosen at random will be in the small square. So the probability of this event is going to be the area of the small square over the area of the large square. And so the probability of this event, we should remember from Unit 6 that to find the area of a square, it's going to be length times width length times width. And so we get 17.97, which we're going to round up to 18. And then 6 times 6 is 36. So instead of equals, we'll say it is approximately 18 over 36. And so the probability of this event occurring is approximately 18 over 36, which is 1/2, which is 0.5 or 50%. And so now we're going to get some more practice with geometric probability using area. So go ahead and turn to the last page. Find the probability that a point chosen at random will lie in the smaller rectangle. So what we're going to do, the probability of this event occurring is going to be the area of the small rectangle, 9 times 3, times over the area of the large rectangle, 15 times 9. And so this is going to be 27 over 135, which is 0.2 or 20%. And I'm just going to double check with my calculator real quick. Yep. All right. Find the probability that a point chosen at random lies in the circle. So the probability that this event occurs is going to be pi r squared, the area of the circle, over the area of the square. And so the probability that this event occurs is pi radius squared over 10 times 10. And so I want you to pause and think here, what is the radius of this circle? What is r? If the diameter is 10, then what is the radius? Hopefully you wrote down 5. So you have 25 pi over 100, which is 1/4 pi, or 785 or 78.5%. For this next problem, we are going to think smarter, not harder. And we're going to kind of cheat a little bit. First, I want to show you that each triangle that in this rectangle is the same. So this triangle, half of this triangle right here is the same as half of this triangle right here. So if their halves are equal, then the whole triangles are equal. And so we have 1, 2, 3, 4 equal triangles. Find the geometric probability that a point chosen at random lies in the unshaded triangle. Well, that is just 1/4, or 0.25, or 25%. So now we approach our last problem. Find the geometric probability that a point chosen at random lies in the shaded circle. And so the probability of this event occurring is going to be the area of the shaded circle over the area of the large circle. And so the probability that this event occurs is pi r squared over pi r squared, where we can clearly see that the radius of the large circle is 4. But what is the radius of the small circle? Hopefully you wrote down 2. And so 2 squared is 4 pi, and 4 squared is 16 pi. And so this is just 1/4, which is 0.25, or a 25% chance of landing in the shaded circle. Thank you for taking your notes with me today, and I hope you have a great rest of your day.